Question 1. So part A, which animal has the least weight? Well, obviously we're looking for the smallest number, which is 725. Make sure you write down the name of the animal, not the weight, so African buffalo. For part B, write down the value of the 1 in the number. So the 1 is in the hundreds column, so that's 100. Part C, work out the difference between these two numbers. So just using your calculator, do 2205, take away 1013, and you get 1192. Now we're told the weight of a blue whale is 20 times the weight of the giraffe. Work out the weight of the blue whale, give your answer in tons. So the giraffe is 800. The blue whale is 20 times as big as this, so you do 20 times 800, which is 16,000 kilograms. But we've got to give our answer in tons. Moving from kilograms to tons, we've got to get smaller. The number is smaller, so we have to divide by 1,000, giving us 16. Question 2. A field is in the shape of a rectangle, width is 70, length is 100. Walks around the edge 3 times, find the total distance walked. So I'd suggest you do just a quick sketch to help you gather your thoughts. So we've got the length being 100, the width being 70. So as we walk around the field 1 time, we do 100, then a 70, then 100, then a 70. So that's the perimeter of the field. So that's 340. But we walk around 3 times, so 3 lots of 340, 1020. Question 3. What fraction of rectangle A is shaded? Well, it's 4 squares out of 15, so it's a fraction, that's 4/15. So part B, shade 40% of rectangle B. Well, 40% is 40 out of 100, which is 4 out of 10. There are 10 squares here, so we need to shade 4 of them. Question 4. On the diagram, mark a right angle with the letter R. Well, the right angles are the 90-degree angles, so we've got 2 we can choose from, either here or here. Write down the mathematical name of this quadrilateral. Well, this 4-sided shape, where you've got 2 sides being parallel, but 2 sides not being parallel, that's called a trapezium. Then part C, measure the size of the angle X. So using your protractor, you have to measure this angle here, and you should get 65 degrees. The mark scheme allowed anything between 63 and 67. Question 4. So on the grid, draw the line with equation x equals -3. Now be careful, that's got to be this vertical line down through -3. Just to think about any coordinates on this line, for example -3, 0, or -3, 1, or -3, 2. The x coordinate is consistently being -3. Now for part B, find the coordinates of M, and M is the midpoint of AB. Well, the coordinates of A is 4, 2, 4 along the corridor, 2 up the stairs. The coordinate of B is 1, 4, 1 along the corridor, 4 up the stairs. Now to find a midpoint, you average the x coordinates, the 4 and the 1, and you average the y coordinates, the 2 and the 4. So to average the x coordinates, you add the 2 numbers together, 4 plus 1, which is 5, and halve it, that is 2.5. And then for the y coordinates, add the 2 and the 4 together, which is 6, and halve it, giving you 3. Now D is the point, so that ABCD is a square. Find the coordinates of D. So we've got this being a square here. So really going from C to D is going to be the same as going from B to A. So you've got to go 3 to the right and 2 down. So going 3 to the right and 2 down from C, we end up with a coordinate 2 minus 1. Question 6. So here is a number machine. So whatever you put into the machine, times it by 4, take away 8 to get the output. So part A, work out the output where the input is 18. So we're putting the 18 in here. So take your 18 and times it by 4. That gives you 72. Then take away 8. That gives you 64. Now for part B, we've got to work out the input when the output is 20. So this is going the other way. We're going from output to input. So we're putting the 20 in here and we're going the opposite direction. So we have to do the opposite operation. So the first thing we do to our 20 is add 8 to it, giving us 28. And then secondly, rather than times by 4, we have to divide it by 4, giving us 7. So the input is 7. We can obviously check this by just going the other way. So 7 is the input, 7 fours are 28, take away the 8, we get 20. Now here is a different number machine. For this machine, when the input is 8, the output is 50, work out the volume of X. So we're putting 8 in as the input, 8 fives are 40. Now then we've got to add something to the 40 to get 50. So obviously X must be 10 to take us from 40 to 50. Question 7. So complete the frequency table here. So work your way through these one by one, left to right, row by row, just putting in a little tally dash as you go. Cross these out as you go so you can make sure you don't miss any by accident. And you end up getting 4, 7, 5 and 4. Now to draw a bar chart of this information, so have your nuts across the bottom, so cashew, walnut, almond and pistachio. Make sure you include the numbers on the side, 1, 2, 3, 4, 5, 6, 7, 8, 9. And obviously the cashew goes to a height of 4, walnut 7, almond 5, pistachio 4. You don't have to leave a gap between the bars, but I think it's nice to do so just to sort of spread it out nicely. Question 8. So y times y times y is y cubed. 3 times c times 2 times d. Well, 2 3s are 6. 6 times c times d is 6cd. Now part C, 2k, then we've got to take away 4k and add 3k. So you can do these any order you like. So you could do 2k plus 3k is 5k, and then take away the 4k to get 1k, which is k, or you could just work your way along from left to right, just comfortably going to the negatives. So 2k take away 4k is minus 2k, minus 2k, add 3k is plus 1k, and we write that as k. Question 9. Which ski resort has the lowest temperature at midnight? So we're obviously looking in the temperature at midnight column. Which of these is the smallest number? Well, it's minus 8, and that's the temperature in Alto Campo. Part B, work out the increase in temperature from midnight to midday for Chamonix. So we're going from minus 5 to plus 3. So just do a little number line to help you gather your thoughts. We're going from minus 5 all the way up to 3. Well, it's 5 to take us from minus 5 to 0, then the other 3, so that's 8. If you weren't wanting to do it on your calculator, you'd have to do 3 minus 5, which would give you the 8. Now, Jan knows the temperature falls by 1 degree for every 300 metre increase in height from Asiago. What was the temperature at midnight at a height of 1800 above Asiago? So midnight temperature Asiago is minus 7, and we are going to have to reduce that temperature. It falls by 1 degree for every 300 meters in height. So this is this temperature at the place we're thinking about is 1800 meters above here. So 1800 divided by 300 means it's going to be a 6% fall in temperature, because for every 1 degree centigrade is for every 300 meters. 1800 meters is 6 lots of this, so it's going to be a 6 degree fall. So we're starting off with minus 7 being the temperature in Asiago. Take 6 away from this, takes us to minus 13 degrees centigrade. Question 10. Write down the probability that the counter is red. Well, we've got 7 green, 10 red, and the rest are blue. Given we've got 20 counters, that must mean that the rest is 3, because 7 add 10 add 3 is 20. So write down the probability that the counter is red. Well, that's 10 out of 20, or you could have simplified that if you wanted. And part B, work out the probability the counter is blue. Well, as I said, we've got 3 blue counters because we're told the rest of the counters are blue. 7 were green, 10 were red, 20 in total, so there must be 3 in blue. That's 3 out of 20. Remember, always give probabilities as a fraction if it's up to you, really. It's a lot easier to do. 3 out of 20, just 3 over 20, job done. Now, Ruth puts the counters back into bag X. Bag Y only contains green, red and blue. In bag Y there are the following. 2 more green counters. So 2 more than 7, which is 9. 1 more red counter, so 1 more than 10, which is 11. And 2 more blue counters, so 2 more than 3, which is 5. Adding those up, we can see we've now got 25 counters in total. Now, who has the greater probability of taking out a green counter, Adam or Keith? Adam takes at random a counter from bag Y. So Adam's taking it from this bag Y. So he's taking a green. So the chances of him getting a green is 9 out of 25. Whereas Ruth picking out of bag X, getting a green is 7 out of 20. Now, it's quite hard to compare and contrast these. Of course, you could convert them into equivalent fractions and so on, but given we can use a calculator, probably best just to convert these into decimals now, which is so much easier to compare. So just on your calculator, do 9 divided by 25 and you get 0.36. 7 divided by 20, you get 0.35. Adam's probability is slightly bigger, so Adam has the greater probability. Question 11. A sequence is formed by adding 1 to each square number. Here are the first 5 terms. Find the 10th term of the sequence. So our first term is 1 squared, which is 1, add 1, which is 2. Our second term, the second in the queue, is the second square number, which is 2 squared, which is 4. 4 and 1 is 5. Our third term here, 10, comes for when you square 3. Fourth one from when you square 4, fifth one from when you square 5. So for the 10th term, it's going to be when we square 10. So we've got 10 squared, which is 100, then add on the 1, which is 101. Of course, you could have just worked all these out just by saying we've got 1, then 4, then 9, then 16, and so on. But if you can spot the pattern and relate it to its position in the sequence, it just makes things a bit quicker. Now, part B, 1025 is the term of the sequence. Which term? So, working backwards. Working backwards, we have to undo this plussing of 1. So we take away 1. So that's 1024. Then to undo the squaring, we square root. The square root of 1024 is 32. So this is the 32nd term in the sequence. Because 32 squared is 1024. 1024 add 1 is 1025. Question 12. Now we've got to work out the value of x. So we can see we've got x here and x here. Now the angles in a straight line add up to 180 degrees. So we know that x plus 1024 plus x has got to equal 180 degrees. So think about it. We've got 180 degrees. Take away 124 degrees, leaves us with 56 degrees, and that's got to be split equally across these two x's. So 56 divided by 2 is 28. 28 plus 124 plus 28 equals 180. Question 13. Now you've got to be ever so careful with these. I mean, obviously we can just pop this into the calculator and get 17 over 24, but we can't do that. We've actually got to go and show this. So we've got to do it without using a calculator. Start off with the left-hand side and just get to the right-hand side. So how do we subtract fractions? We need to have a common denominator. Now 8 and 6 do both go into 48. That would be fine. 8 6s are 48, but a smaller common multiple is 24. They both go into 24. So I'm going to choose to have my equivalent fractions being over 24. So how do I turn my 8 into 24? I multiply it by 3. So to keep the fraction unchanged, I've got to multiply my numerator by 3 as well. 7 3s is 21. Moving on to the second term, 6 4s are 24. So multiply the numerator by 4 as well. 1 4 is 4. Now we've got a common denominator, we can just subtract the numerators, the top numbers. 21 take away 4 is 17 over 24, which is what we had to show. Question 14. So work out the value of y when we've been given c, d and x. So first things first, just substitute in. Replace these letters with these numbers. So y equals c, which is 15, then take away d times x, which is 8 times minus 4. 8 times minus 4. And you've got a mark for that. So 8 times minus 4 is minus 32. So it's 15 minusing a minus 32. Now minusing a minus is a plus, so that's 15 add 32, which is 47. Now you could have just popped that line straight into your calculator if you include the brackets. Now part B, a bit more going on here because we've got to work out one of the items on the right. So start off the same way. Start off just by substituting in what you know. So we know t is 18, so 18 equals, then the 4, open the brackets, p we don't know, but then we've got to take away q, so we've got to take away 6. So you could multiply out the brackets, that would be absolutely fine, that would be one way to go about doing this, but what I've chosen to do instead is just to start off by dividing by 4. So 18 divided by 4 is 4.5, so 4.5 equals p minus 6. Add 6 to both sides, I get p equaling 10.5. Question 15. So we've got 440 students in the school and we're told the number of males is 40 more than the number of females. So 40 more males. So if we've got 200 females and 240 males, we can see that's 40 more males, and those two together add up to 440. Now we're told that 65% of the male students like art. So we need to find 65% of the male students of the 240. So just pop into your calculator 0.65, because that's 65% as a decimal, 0.65 times 240, and we get 156. Moving on to the females, 85% of those like art, so we need 85% of 200. How do you work out 85% of something? Do 0.85 times 200, giving you 170. So these are the boys who like art, the girls who like art, so the total number of students who like art, you add these two together to get 326. Question 16. So we've got to work out the area of this hexagon, so this total shape. Now this isn't that easy, but you've just got to use a good exam technique and pick up the easy marks where you can. Now we break this shape down into 2 bits, so like the roof bit if you like, and then the sort of the rectangle underneath. Now there's an easy mark going for just working out the area of this rectangle. So the base is 20, the height is 14, so the area of that rectangle is 280. So that's one mark. Now this roof shape is a trapezium. You've got 2 parallel sides and 2 non-parallel sides. So how do you work out the area for a trapezium? Well, you average the 2 parallel sides. So we're averaging the 16 and the 20. Of course the length from B to E is the same as the length from A to F. Now the average of 16 and 20, well, you add them together and halve it, which is 18. And then you times that by the depth of the trapezium. Well, that length there is 10, because the total height all the way up is 24, yet that part there is 14. So that bit there must be 10. So the area of the roof bit, the trapezium, is 180. The rectangle underneath is 280. Add these two together, you get a total area of 460. Question 17. So we've got to reflect triangle S in the line y equals x. Now that's this diagonal line here, where every point on the line, the x coordinate equals the y coordinate. For example, 1, 1, or 2, 2, or 3, 3. The y coordinate and the x coordinate are the same. So that's our mirror line. So just reflecting all the points across. This diagonally is just going across to there. This point here is going across to here. And this point here goes across to there. So that's our shape R there. Now translate triangle S by this vector. Well, a vector sort of works a bit like a coordinate really. This is 4 to the left, and then 6 down. So just think of it as just like a coordinate. This is the one that takes you left or right, the bottom one takes you up or down. So we've got to move triangle S 4 to the left and 6 down. So take a point of your choice just so you don't lose where you are. Move that 4 to the left, 1, 2, 3, 4, and then 6 down and takes you to here. That's my bottom left hand corner of the triangle. So fill in the rest of the triangle and I get that. Now I've got to describe fully the single transformation that maps triangle P onto a triangle Q. Now I've never seen one of these before where there was only 2 marks going for it. Normally these are 3 markers. Anyway, 3 points we need to make. We need to make the point that it's an enlargement, and then we've got to make the point that it's a scale factor 3. Each side is becoming 3 times longer. For example, the base has gone from a length of 1 to a base of 3. But the third point you have to make, the centre of enlargement is 0, 0. So how do we work this out? Well, you take corresponding points on the 2 shapes and draw in sort of like a mirror line, sunshine ray if you like. And then take a second common point. I've taken the bottom right. Again, just draw in a line connecting those and extend that line. Now where these 2 lines intersect at 0, 0, that is our centre of enlargement. Question 19. So we've got to calculate an estimate for the mean time these students spent doing sport. So I think really to do these, you really need to understand what's going on. This table gives us information about the times and hours spent by some students doing sport. So 5 students spent between 0 and 2 hours each week. 9 students spent between 2 and 4 hours, and so on. Now the thing is, we don't actually know how long these students actually spent. We just know it was between nothing and 2 hours, or 2 hours and 4 hours. So we actually have to estimate how long they spent, and that's why it's an estimate. So they spent between 0 and 2 hours. So the best we can really do is go down the middle and say, well, let's assume they all spent exactly 1 hour exercising. And this row here, let's say they spent exactly 3 hours exercising, and so on. So we take a midpoint. So these are normally easy to see. You just see what the middle number is. If it's a bit trickier, the midpoint is just the average. So just add the 2 numbers together and halve it to get these midpoints. Now for the rest of the question, that's how long we're going to assume they spent exactly exercising. So 5 people spent exactly 1 hour. 9 people spent exactly 3 hours, and so on. So to work out the total number of hours, we just cross multiply. 5 people spent 1 hour, that's 5 hours in total. 9 people spent 3 hours, 9 threes are 27, 27 hours in total, and so on. So we go and add up all of these lots of hours to get 495 hours. Now we need to spread those hours across the number of students that we asked. Now how many students have we got? Well, quite often this is given in the question. It isn't on this occasion, so you've got to add up the frequency column. This tells you how many students there are. Here are 5 students, 9 students, 24 students, and so on. So add up the students and we get 85. So 85 students spent 495 hours in total doing sport. So what's an estimate for the mean average? 495 divided by 85 is 5.82 ... So correct to 1 decimal place, that is 5.8 hours. Question 19. So Anna and Lionel share $675 in the ratio 4 to 5. So let's split that first of all. So 4 to 5 is the ratio they split it. Now that's 9 shares in total. So let's spread this 675 across 9 shares. So we do 675 divided by 9, and then multiply this by 4 to get the number, the amount of money that Anna gets, and multiply this by 5 to get the money that Lionel gets. So Lionel gets $375 in total. Now, of this, he gives 3/5 to his mother. So we've got to work out 3/5 of 375. So using the fractions button on your calculator, that's about 4 down on the left-hand side, I think, that the little rectangle divided by the little rectangle. Put 3 in the top rectangle, 5 in the bottom rectangle, then multiply this by 375, and that gives us $225. Question 20. So part A, work out the value of E when n is 3. When n is 3. So we're just going to substitute 3 into the right hand side. 3 squared, add 3, add 5. So 9, add 3, add 5 is 17. Now for part B, Ali thinks that the value of E will be a prime number for any whole values of n. Is Ali correct? You must give a reason for your answer. So what we really want to do in one of these, if we can find an example where she's not correct, then we can just conclude that they're not right. So so working through, it does work for n is 1, 2 and 3, but look what happens when you do n is 4 or n is 5. Let's do n is 4 for example. 4 squared is 16, 16 add 4 is 20, add 5 is 25. Now 25 is not prime because 5 5s are 25. Same with when n is 5. So as we found one example where it doesn't hold true, we can conclude that Ali is not correct. It's a lot harder to prove that somebody is correct because you've really got to go through all the possibilities. So on one of these, you're really expecting the answer to be they're not correct, and you're just trying to find an example to prove that their statement doesn't hold in all circumstances. Question 21. So working our way around this, we've got to work out this little angle up here, ABG, this little small angle here. So how do we go about that? Well, first things first, we can work out that this angle here must be 77 because angles in a straight line add up to 180. So 180, take away 38, take away 65, gives us x being 77. Now, given that that's 77, the whole of ABE must also be 77. That big angle there must also be 77 because alternate angles are equal, sort of z angles. So that big angle there all the way around is the same as that, which is 77. So that's one thing we know. Now we're told that this is an isosceles triangle in here. Well, we're told we can see that because we're told that the angles well, that little dash is telling us that that side is the same as this side, so these two base angles must be the same. So given this is 65, this is also 65. Angles in a triangle add up to 180, so the angle that I've marked as being y must be 180, take away the two lots of 65, which is 50. Now, I'm trying to work out this little angle here. I know that this big angle, ABE, is 77, of which y is 50, so this bit must be the bit left over, so that's 77, take away 50, which is 27. Question 22. So we've been asked to find an expression in terms of n for the nth term. So this is really just a little process you need to follow. So we're going up in 4s, so the first term is going to be 4n. Had we been going up in 5s, it would be 5n, and so on. And then this second term, this little adjustment we have to make, think of that as the 0th term. Think of that as the number in front of the real numbers. So just picture these people lining up in a dinner queue. This is somebody pushing in at the front. So what number would this be? Well, going from right to left, we can see we're going down in 4s. So 6 take away 4 is plus 2. So this, what we call the 0th term, is plus 2. So 4n plus 2. Now what would be the next term in the sequence? Well, we've just got to add 4 onto this. So that would be 4n plus 2 plus 4, which is 4n plus 6. Question 23. So both of these numbers have to be written in standard form. Now remember the rules for this. The first number must be between 1 and 10, and then it's times 10 to the power of something. So first number first. So we need to start off having a number between 1 and 10. So the decimal point would have to be between the 1 and the 3. So that's why it's 1.39 times 10 to the something. Now it's a big number, so our power is going to be a plus number. So what is this number? Well, the decimal point effectively starts at the end and has to move to between the 1 and the 3. So hopping across, that's 1, 2, 3, 4, 5, 6 hops, so the power of 6. Now part B, again we need the first number to between 1 and 10, so that's got to have to be the 5 times 10 to the something. It's going to be a minus because we're dealing with small numbers. And then again, where does the decimal point have to, how many hops does it undertake? Well, it starts here. It's got to end up after the 5. So that's 1, 2, 3 hops. So 5 times 10 to the minus 3. Question 24. Now this is quite a difficult question, but again, be smart, be exam smart, pick up the easy marks. And there was just 1 mark going for just making it clear you understood that because the level of the water will be 60 centimeters below the top, that this must be the depth of the water. So 60 centimeters is 0.6 of a meter. The level of the surface of the water will be 60 centimeters below the top of the pool, so that is 0.6 meters. Now, given that the total pool depth is 2.5 meters, the height of the water must be 1.9 meters. So 1 mark going for the 1.9, and that was pretty straightforward. Now, we need to work out how much water is in the pool. This is a volume of a cuboid, so we just need to do base times depth times height. So 3 times 12 times 1.9, and that gives us 68.4 meters cubed. Now, converting this into litres, 1 meters cubed is 1,000 litres, so we have to times it by 1,000, so we have 68,400 litres of water in the pool. Now these fill up, the pool fills up at 400 litres per minute. So 68,400 litres at 400 litres per minute, divide the 68,400 by 400, this is going to take 171 minutes. Now turning that into hours and minutes, 60 minutes in an hour, so that's 2 hours we can fit into this, using up 120 minutes, 51 minutes in addition to this, so 2 hours, 51 minutes. Question 25. Now, to solve a simultaneous equation, we have to have the same number of x's or the same number of y's. The sign doesn't matter, but we've got to have the same numerical value. So what I've chosen to do is to take my first equation and double it, because that's going to give me 4y, which will line up with the other 4y. So my first step is to take equation number 1 and to double all 3 terms. So 2 lots of 3x is 6x, 2 lots of plus 2y is 4y, and 2 lots of 15 is 30. So now I can compare this new equation with the second equation here, the 10x minus 4y equals 2. Now, because I've done this doubling, I've now got 4y in common with both these equations. Now, because the signs of the 4y's are different, I need to choose to add these 2 equations together, because 4y added together with a minus 4y will eliminate the y's. So I'm choosing to add these 2 equations together. If I did take them away, I'd have 4y minus 4y, which would be 4y add 4y, which would be 8y, which would not have eliminated it. So the key bit is you must add these 2 equations together. 6x plus 10x is 16x. 4y added together with minus 4y is nothing. That was the whole point. 30 add 2 is 32. So 16x equals 32, so x must be 2. X is 2. Now I then need to work out what y is, and to do this is a separate process altogether. I need to take my 2 that I found to be x and substitute it back into either of these 2 equations. Now I'm taking the top one because I just prefer working with pluses. So I'm starting off with 3x plus 2y equals 15, and using the fact that I now know that x is 2. So 3 lots of x is 3 lots of 2, which is 6. So 6 add 2y equals 15. Take away 6 from both sides, I have 2y equaling 9. Divide by 2, I have y being 4.5. Question 26. Now I need to change the speed of 72,000 kilometers per hour to a speed in meters per second. So just take your time, do it bit by bit. So first of all, I'm going to change kilometers into meters. So there's 1,000 meters in a kilometer, so I'm going to times this by 1,000. So that's 72,000 meters per hour. Now I need to change it from hours to seconds. So first of all I'm going to divide by 60 to take me into minutes, and then divide by 60 again to take me into seconds. So 72,000 divided by 60 divided by 60 again gives me 20 meters per second. Question 27. So we're told in the first 6 months of 2017 the company made 25 cars each month. So for 6 months it made 25 cars each month. So that's 6 times 25, which is 150. And for the other 6 months it made 45 cars per month. 6 lots of 45 is 270. So in total it made 420 cars in 2017. Now we're being asked to work out the percentage increase going from the 350 in 2016 up to what we've just worked out, the 420 in 2017. Now to work out a percentage increase, you take the change, so the increase in this question, divide it by the original amount and times it by 100. So how many more cars is it producing in 2017? Well, 420 take away the 350 is 70. So 70 more cars divided by the original amount of 350 times 100 to turn it into percent, and that's 20%. Now for part B, this is quite complicated. We're told that the company's income in 2017 was $500,000 more than the company's income in 2016, but also exactly the same wording, but this represents 8% more. So we're basically being told that 8% is the 500,000. So 8% represents the 500,000. Now we want to work out the total company's income, so that's really the 100%. So we need to go from 8% to 100%. So to do that, I first of all divided by 8 to take me back to 1%. So 1% is 62,500. Multiplied this by 100 to get the 100%. That gives me $6,250,000.